In solving an equation in function notation, we can pretend that this function is a machine, and our value that we're plugging into the machine is the input, which is x, and the value coming out of the machine is gx, or the output. If we were to set this up as a table, we would put x on the left and gx on the right. In this way, gx is very similar to y, which is what we've used previously when we were not using function notation. Now that we are using function notation, the only difference is that we are now using g, the function. The only difference is that we're now saying that x is a function of g by writing it like this. So let's go ahead and try A, B, and C. In this first problem, x equals 4. In the second one, x equals 3c. And in the final one, x equals 2. And then at the very end of the problem, after we solve the function, we can add 7. So let's go ahead and try these. So if x equals 4, that means that in place of x, we're going to write a 4. So I'm going to rewrite this as g4 equals 4 minus 2 times 4 squared. Then we just use order of operation. So that means we're going to focus on the exponent first, so we get 4 minus 2 times, and then we've got 4 squared, which is the same as 4 times 4. So we get 4 minus 2 times 16. We've done E. Now we're going to go ahead and multiply. We added these parentheses in, so we skipped that. Multiplication means we've got negative 2 times 16, which is negative 32. Bring down the 4. No division, no addition, so our final step is subtraction, and we get that this is equal to negative 28. So you can write your final answer as G4 equals negative 28. In this problem, x equals 3c, so that means 3c has to be plugged in for x in both locations. So to rewrite this, we write G3c equals 3c minus 2 times the quantity 3c squared. So both 3 and c have to be squared because they're going in place of x. Here we use the power law, so that means that we multiply the exponent outside of the parentheses by the 2 inside, so we get 3c minus 2, and then we've got 3 to the power of 2, c to the power of 2. Again, there's order of operation. There was only parentheses because of the exponent, so we start here. Now we still have an exponent, so we're going to rewrite this as 3c minus 2 times 3 times 3, which is 9c squared. Now we're moving on to multiplication, which in this case means we're going to go ahead and multiply 2 times 9. So we've got 3c minus 2 times 9, which is 18c squared. C and c squared are not equal. So that means that these are different variables. So that means we cannot combine like terms because we don't have like terms. So that means here that our final answer for this problem is right here. We're just going to leave it right like that. You could technically factor and pull out a 3 if you wanted to, and a c, but there's no need. This is a fine answer. Finally, here we are told that we have a function to solve, and then after we solve this function, we are going to add 7. So that's going to happen down here at the end. Until then, we can ignore that. So we've got g to the negative 2, which means that x equals negative 2, and that needs to be plugged into both of the x's. So we have negative 2 minus 2 times negative 2 squared. Exponent first, so we get negative 2 minus 2 times, and then this is negative 2 times negative 2. Two negatives make a positive, so we've got 4 when we multiply. And we have multiplication, so we're going to do this. Negative 2 minus negative 2 times 4 is negative 8. Add these together, or because they're both negative, so you end up with negative 10. And then this is when you're going to bring back in the 7. So you have negative 10 plus 7 equals negative 3. Since this plus 7 was not inside the parentheses, it does not go into the function machine, so that's why it's left until the very end. Remember to think of this as a machine, and only the negative 2 is going in. Once we have our output, that's when you add 7.